So let's draw the root locus for this question. Okay. So we have to simplify this question. K into s plus 2 divided by s square plus 2s plus 1, which is open loop transfer function. That is characteristic equation was given. Okay. So we will simplify it in the root form. So poles are at -1 plus j, -1 minus j, and zeros are at -2. So we are plotting here -1 plus j, -1 minus j, and -2. So from this, by plotting these location of roots and roots, we find the where the root locus is existed. Okay. So here root locus is existed. That is total number of poles and zeros are at right side should be odd number. Okay. So here the root locus exists. So p minus z equal to 1, number of poles minus number of zeros equal to 1. So 180 degree angle of asymptote is there, and centroid is total real part of total real part of pole minus total real part of sum of real part of zeros divided by p minus z, which comes 0. Okay. So yeah, that is here 0. Centroid is here at 0. And we find dk by ds. So okay, dk by ds by simplifying s equal to -6 and s equal to -3.4. So which is satisfying on the root locus. So it is not satisfying at the root locus because 0.6 is lies here. Okay. So it is the satisfying the root locus. At root locus it is -3.4. Okay. So if here root locus is satisfying at s equal to -3.4, which is break-in point. Okay. It means it arrives at the root locus. Okay. It arrives at the root locus. So if we will find the k here, if we will find the so if we will find the k here, okay, k to comment about the over damping, under damping, and critically damping. So we have to find k here. It means at pole k should be k equal to 0, and at zeros k equal to -infinity. Okay. K equal to infinity. K equal to infinity. So we will find at breakaway point for to find the k. So k into s plus 1, which is k equal to 1. So k is coming 4.8. So okay, k is coming 4.8. So it means root locus also, and the here the poles, it means whenever the roots are at complex, then we have, whenever the roots will be it means complex, if poles are at complex, then we have to find angle of departure, and when the zeros are complex, then we have to find angle of arrival. Okay. So here poles are at complex, so we have to find angle of departure. Okay. So angle of departure angle of departure is plus minus 180 degree plus phi, and phi is the net angle contribution. Okay. Phi equal to net angle contribution. So for phi, just look here. It means just take a reference above the pole. Okay. Take reference which is lies uppermost. Okay. So here angle is coming 90 degree, and here angle is coming, it is 1, and it is also 1. So angle is 45 degree. Okay. So minus for pole, minus negative for pole, and what angle makes plus 90. From plus 90 it goes plus 90, and plus for zeros, and zeros making angle of plus 40. So it comes minus 45 degree. So angle of departure is plus minus 180 degree minus 45. It means plus 5. It means 5 equal to minus 45. So plus minus 135. So 135 is coming at here plus 135, angle of 135, and here at minus angle of 135. So root locus will goes like this and meets at breakaway point. And it goes like this and meets at breakaway point. Okay. And it will goes here, and another will go in this direction, because from the centered it is angle of asymptote is only 180 degree, so it will goes 180 degree. So this is the final root locus diagram. Okay. So it means here in the real axis it will be over damp, and in the above the real axis it is the under damp. above the real axis is the under damp condition. So k equal to 0 here and k equal to here, we find a 4 point height. It means k equal to 0 to 4.8, it is under damp, and k equal to 4.8 to k equal to infinity, k equal to 4.8 to infinity, it is over damp, and at k equal to 4.8 critically damp. Okay. So we move to the next question.